Hi everyone, this is Amarpreet Jetra from IIPS DAVV Indore. I am going to explain the solution for NAD Internal-1 QUE-3. The question was to calculate the value of polynomial for x equals to 4.0110 using floating point arithmetic with 4 mantissa using two approaches and compute the relative error. The two approaches that we have to use are straightforward determination and nested parenthesis method, where px equals to x cube minus 4x square plus 0.1x minus 0.5. Now let us move to the solution of this. First of all, using straightforward determination, here we will be calculating the individual values of x cube, 4x square, 0.1x and 0.5. First of all, calculate x cube by using the value of x given in the question. Hence, multiplying 0.4011 E1 3 times, we will be getting the answer as 0.6449 E2. This is equation A. Now calculate minus 4x square by using the value given in the question for x, and the final answer we are getting here is minus 0.6435 E2. This is equation B. Now calculate 0.1x by using the same value of x that is given in the question, and thus we are getting the value for 0.1x equals to 0.4011 E0. This is equation C. And at last, minus 0.5 can be written as minus 0.5000 E0. This is equation D. Now add equation A and B, and thus we will be getting x cube minus 4x square as 0.1700 E0. This is equation 1. Now add equation C plus D. Then we will be getting the answer for 0.1x minus 0.5 as minus 0.0989 E0. This is equation 2. Now add the two equations, that is equation 1 and equation 2, and thus we will be getting the value for the given polynomial, and the final answer we are getting here is 0.7110 E minus 1. Now the second approach we have to use, that is using nested parenthesis method. The equation given in the question, that is x cube minus 4x square plus 0.1x minus 0.5, can also be written as minus 0.5 plus x into 0.1 minus 4x plus x square. Now again taking x common in the bracket, we are getting minus 0.5 plus x into 0.1 plus x into minus 4 plus x. Now solving polynomial in parts from right hand, we get minus 4 plus x equals to 0.1100 E minus 1. Let us take this as equation A. Now multiply x with A, we are getting 0.4412 E minus 1. This is equation B. Now add 0.1 with B. Then we are getting the answer as 0.1441 E0. This is equation C, and multiply x with C, we are getting answer as 0.05779 E1. This is equation D. Now add D to minus 0.5, and thus we are getting the answer as 0.7790 E minus 1. Hence the final answer for the given polynomial, that is for x cube minus 4x square plus 0.1x minus 0.5, we are getting the answer as 0.7790 E minus 1. Now here we also have to calculate the relative error. For calculating the relative error, we have to calculate the value of polynomial using 8-digit arithmetic. In simple words, here we have to determine the answer for each individual calculation up to 8 decimal places. So for x cube, we have to determine the answer up to 8 decimal places. So the answer will be 0.64529453 E2. This is equation A. Similarly, minus 4x square, by using the value of x given in the question, we are getting answer as 0.64352 E2. This is equation B. Then again 0.1x equals to 0.40110000 E0. This is equation C. Then minus 0.5 equals to minus 0.5000000 E0. This is equation D. Now add equation A and B, and we are getting x cube minus 4x square as 0.00176969 E2. This is equation 1. Now add equation C and D, and thus we are getting 0.1x minus 0.5 as minus 0.0989000 E0. This is equation 2. Finally, as we have done using straightforward determination, add the two equations, that is equation 1 and 2, and thus we are getting the value for polynomial as x cube minus 4x square plus 0.1x minus 0.5, and the final answer we are getting here is 0.7807 E minus 1. We can see that the value here we are getting is 0.7807, which is different from the one we have find using straightforward determination. Now percentage error in method 1, that is in straightforward determination, this can be calculated by using the formula 0.7807 minus 0.7110 upon 0.7807 into 100, and thus by solving this equation we are getting the percentage error as 8.9%. Now percentage error in method 2, that is for nested parenthesis method, we are getting 0.7807 minus 0.7790 upon 0.7807 into 100, and thus we are getting the relative error here is 0.2%. Let us move to question B, that is develop an algorithm or flowchart or Python code or C routine or MATLAB code to find cube root of any number using bisection, false position, second method, successive approximation method. The solution for this is, let us take x equals to n to the power 1 by n to the power 1 by 3, where n is number whose cube root is to be determined. Now here x cube equals to n, thus f of x can be f of x, that is x cube minus n, equals to 0. Now apply bisection method to find the root. The algorithm is as follows. First of all, read x0, x1 and e. Remark here is x0 and x1 are two starting points which encloses the root, and e is the error allowed. Now put f of x0 in y0, then put f of x1 in y1, then initialize I to 0. Now check if sign of y0 equals to sign of y1, then write starting values are unsuitable. Then write the value for x0, x1, y0, y1 and stop and end the algorithm. Then check the condition. If x1 minus x0 upon x1 is greater than e, then put x0 plus x1 upon 2 in x2, then put f of x2 in y2, increment I by 1. Now check if sign of y0 is equal to sign of y2, then put x2 in x0, otherwise put x2 in x1 and end the if statement. Write solution converges to a root, write number of iterations, that is I, then write the value for x2 and y2 and stop the algorithm. This was the solution for the above asked question. Thank you.